Hello, am I audible? Let me check my audio before we get started. If I am audible, please say yes in the YouTube live chat. So that we can all get started. Welcome to Blockchain Free Webinar Series from Mad Blockchain Group of Mad Blocks Technologies Private Limited. So I warmly welcome you all to the great evening with us on blockchain implementation using Python. In our we are going to discuss about how to create a block and blockchain right from scratch using Python programming language. If you have any queries in related to the webinar, you can drop me a message. My mobile number is scrolling down to this YouTube live. You can message me on that if you have any questions. So this is the fourth successive webinar. So in the previous three webinars, we have discussed about how to create a smart contract in the first webinar by using Ethereum blockchain. And the second webinar, we have discussed about how to write a Solidity program, and also we have discussed about the syntaxes of Solidity in the second free webinar. You can check it out in our YouTube channel. And in the third webinar, we have discussed about how to use Ganache, how to use Truffle framework in order to create decentralized web applications. So in the third webinar. So in the fourth webinar, we wanted to create Python programming language. So this is the fourth webinar in the webinar series. So if you miss the previous three webinars, you can go through the YouTube channel and you can stream it back. So this is Madhu Parvataneni signing in for the webinar. I am the director and strategist at MadBlocks Technologies Private Limited. So I will be your instructor in this webinar. Can we all get started? Hope my audio is audible and also my screen is visible so that we can all get started. If you have not registered in the webinar, you can register on the URL which has been displaying on the slide, which is bit.ly/free blockchain webinar 4. Okay, we will be sending you an e-certificate. If you have not registered, you can register now. And also this URL is sent in the video description also. So in the video description, you can able to see the same registration URL. You can click on it. So before I discuss and start the webinar, let me tell you that so I have written a blog on this video, on this free webinar on medium.com. So that link is also available in the video description, and also I have written some programs related to this webinar. So that GitHub link is also available in the video description. So make sure that you have those links with you right away. So the blog link is also mentioned in the video description, and also GitHub link is also mentioned there. So in this webinar, I am using that blog link and also GitHub link in order to develop some applications on using Python on blockchain. So let me get started. Let me open that blog URL also in order to show you what I have written there. So I have written in just in 1 hour back I have written this article on medium.com, which is like build a mini blockchain using Python in just 15 minutes. So in 15 minutes you have to create a mini blockchain application using Python. So this link I have shared in the YouTube video description. Okay, in the webinar video description we have shared this URL, and also I have written some programs like which is my first mini blockchain Python. So that is also given in the YouTube video description. You can click on those links in order to see what is the content. Okay, so let me jump back to the blog, which is like build a mini blockchain using Python in 15 minutes. So let us discuss. So in the previous 3 webinars we are talking about blockchain, right? So what is blockchain? So from there our discussion will start. Okay, let me zoom it for you. What is blockchain? So this is the main discussion, right? So that we were discussing in the last 3 webinars is that blockchain is a technology, or it is an implementation of distributed ledger technology where the data cannot be tampered and also your data is open to everyone. So which indirectly means that which removes a third party which is between the owned entities there. So when you have one entity and the second entity, the first person and the second person, so if you want to make a transaction in between first person and second person, so the blockchain technology will be removing the third person in between them, right? So which is like the owned entities. So say first person and second person are the owned entities. They want to make a transaction. For example, say I want to transfer a 10 bitcoins to my friend. So if you want to transfer some money to a friend, you need some bank accounts and all, right? So those bank accounts are in between us, right? So when you look at blockchain, so you don't need any bank, you don't need any bank account. Okay, you need a crypto wallet address. So if you have a crypto wallet address, I can transfer the money immediately from me to my friend, so without any third party here. So what is blockchain? Blockchain is nothing but an implementation of distributed ledger technology where the data cannot be tampered. Blockchain is a database where your data is getting stored, and the stored data is immutable and transparency, right? It is transparent to everyone, it is open to everyone, anyone can view the data, but they cannot update the data, they cannot tamper your data. It means that the data cannot be modified once the data is added to the block. So thus it increases the security for the data that is getting stored in the block, right? So that is why people say blocks are immutable. So blocks are immutable, you cannot tamper the data. Once the data is uploaded into the block, once the data is inserted into the block, you cannot do that, right? So for a beginner to understand, it is a technology where all your data is getting stored, so in terms of database, but the blockchain network is acting like a database where it stores the data, and it is impossible to hack. So that is why blockchains are coming in different domains, right? So people are talking about blockchain in agriculture, people are talking about blockchain in health science, people are talking about blockchain in aviation. So there are different types of domains where blockchain can be easily implementable. Okay, in the free webinar series we will be also talking about various use cases slowly. As the days goes on, we will be talking about the real-time use case studies also, but as of now let us understand how to create a blockchain from scratch using Python programming in the today's webinar. Okay, and also we should understand why we need a blockchain. So when you store your data in the server which is maintained by a third party corporate, it is no guarantee that your data will never be tampered. The hacker can hack the third party server and all the data can be lost. Say if you store some data in Facebook, say if you store your images in Facebook, okay, what is Facebook? Facebook is a third party server, right? So you are uploading images from your mobile phone to the Facebook app, and what Facebook app is doing there? Facebook app is uploading the data onto the Facebook server. So what hacker will do? Hacker will download those kind of photos from the Facebook server. They tamper your data. And they will use it for explicit content. So then what will happen? Then hacking is possible there, right? Tampering of data is possible there, right? So that can happen on a centralized server, which is a non-blockchain server. But when you look at blockchain, so no one can tamper your data, which is like, your data is safe and your data is distributed. Say for example, say if the hacker hacks the centralized server, if the hacker hacks the Facebook server, then what will happen? So you cannot access your Facebook account, right? Which means that if a server is centralized, if the hacker hacks your server, then you cannot access your data. But when you look at blockchain, in blockchain your server is distributed, so you'll have multiple number of servers running in parallel through a decentralized network in blockchain. If server hacks one server, what will happen? Your application will be connected with another server. So because all the servers will have a duplicated networks, okay, so whatever the data is hosted in server 1, the same data will be available in server 2. So there are multiple number of servers which are duplicated servers which are distributed across the network, and these multiple servers running in parallel through a decentralized network, so our applications can able to work properly, isn't it? But when you look at centralized case, you'll have only one server, you'll have multiple number of clients, you'll have only one server, your server is not duplicated, your server is not distributed. So then hacker can hack your server directly, so there is no point of using your application then. But when it comes to blockchain, since it has multiple servers distributed here and there, if hacker hacks one server, you will get a connection with the another server which is distributed across the globe. So here what is the case? So say a hacker hacks your server, so there is no issue here since we have multiple servers run our application. Second, there is no chance of tampering your data. Your data, you cannot tamper it. So why you cannot tamper, that will let you know in the next few minutes. But as of now, your data cannot be tampered and your data is encrypted, so no one can view the data. They can view the data but they cannot understand what it was, so which is like, your data will be encrypted. Okay, so and that is why we need a blockchain. So hackers cannot hack your application, hack your server, because servers are distributed across the globe, and they cannot tamper your data because the data is encrypted and the data is getting stored in the block of the blockchain network. So here in this webinar I wanted to discuss so a few important points that is also penned down in this article. One is called hashing, because I wanted to show you how to create a blockchain from scratch using Python, right? So we have to understand some terminologies. On the webinar 1 also I have explained this, so let me brief it for you if you are a newbie. What is hashing? What is Genesis block? Who is miner? What miners do? What is proof of work? How to validate a blockchain network? So these are the 5 quick points which I wanted to highlight in this article and also in the webinar also. So every webinar I wanted to write an article so that if people miss webinar, they can view this article, right? So generally what happens with webinars is, so generally my webinars are taking long, so sometimes my webinar goes around 2.5 hours and 3 hours, right? So when it is going around 3 hours, people with mobile data, they cannot access my webinar. So that is why I came up with an alternate plan wherein I thought of writing article for every webinar. So if people miss my webinar video, they can go through the article, they can understand easily. So that is why I came up with the concept of article. Okay. So what is hashing? What is Genesis block? Who is miner? What miners do? What is proof of work? How to validate a blockchain network? So let us understand these terminologies. What is hashing? As we discussed in the blockchain technology, all the blocks are tampered free. So because every block is holding a fingerprint called hash. So in the human beings, we have a thumbprint, right? Our thumbprint will act like a fingerprint, isn't it? And also we have iris recognition also. So your iris and thumbprints are like, they're like recognition systems, right? So in the similar way, every block in the blockchain technology will have a unique ID, which is nothing but fingerprint, which is called as hash in the blockchain network. Okay. Now what is hashing? So hashing is a process of convoluted value. So your data, it indirectly means that your data will be, I am Madhu. So here in between I and M there is a single quotation, okay? So hi, I am Madhu. So this is a string data. So this is a string data which I wanted to write onto the blockchain. then immediately I have generated a hash value. So I'll let you know how to generate this hash value. As of now, I have generated a hash value which is a programmatic hash value for the mathematical equivalent of the string data hi I single quotation m Madhu, okay, which is hi I'm Madhu. So a hash value is generated here. If you see, I have quoted the hash value also, okay, for the string data which is hi I am Madhu. Now what I'll do is I'll modify this data. If someone tampers your data, okay, what is tampering? Tampering is nothing but modifying the data. Say I have modified the data. If I modify the data, then you can able to see here. If I modify the data, what I modified here? Hi I am Madhu. There is no single quotation here. So the data is same, but I have modified in such a way that I have removed the single quotation in between I and m. So simply I have written hi I am Madhu. So here again a hash value will be changed. So whenever you change data, then immediately hash value will be changed. You can able to see a new hash value which is generated there, which means that whenever you change your data, say I used to live in Hyderabad, okay, then hacker edits that value as in the place of Hyderabad he has written Bangalore, okay. Say hacker has updated my value which is Bangalore, then what will happen? A new hash will be generated, because with Hyderabad there is already hash generated there, okay. Whenever he updates a value, immediately a new hash is generated. Whenever a new hash is generated, then we can easily identify that your data is tampered. So here in blockchain we can easily identify whether data is tampered or not. Generate this hash, that we'll see later in few minutes, but as of now we need a concept of hashing. So what is hashing here? Hashing is nothing but which gives fingerprint, which gives unique identity to the block, okay. If the data is not if the data is not tampered, so you'll get a same hash value. For example, say you write hi I am Madhu like this 100 times, so every time you'll get the same hash value, okay. Your hash value will never be updated until unless data is modified. If the data is modified, you'll get a new hash value. If it is a old data, then you'll get old hash value only, okay. So that is what you have to understand. That is what I have written here. When you compare two strings, the string is little bit modified, isn't it? So we have modified the string here. In the place of a single quotation, here there is no single quotation, so I have modified a string. So when you compare two strings, the string is little bit modified, thereby hash is also modified. If the data is not modified, so the same hash would be generated every time. So that is what you have to understand. Blockchain will have a unique hash value alias fingerprint of the block. So in the process of hashing in the blockchain, developers mainly use SHA-256 algorithm in order to generate a hash code for your block. So here, as we wanted to write a blockchain from scratch, so we have a library called hash library, okay. Hash library is a built-in library in Python in order to convert your string data into a mathematical equivalent value called hash, okay. Hash is nothing but a unique value, a unique mathematical value generated from the string data, okay. That's all, right? Simple. So okay, let's jump into the next one. So that's all about hashing. So according to me, as of now, because right from the first webinar I'm telling this, your hash is nothing but unique identity given to the block. So again I'm repeating, this blog tutorial is available in the video description. You can click on it, you can open and you can see, okay, what is written there, okay. Block, Genesis block, as the name suggests in the blockchain. So what is blockchain? Blockchain is nothing but a chain of blocks connected with each other using a hash value. So they are connected in terms of chain, right? So blockchain is nothing but chain of blocks. How this chain is framed? This chain is framed based on the hash value. If you want to code a blockchain, you have to create the first block, and that first block is called Genesis block. So if you want to create your own blockchain, you have to create your own Genesis block, isn't it? So the blockchain owner or developer will have a right to create their own Genesis block, ideally the first block of blockchain. So here the target is to create blockchain from scratch. So that is why you have to understand all about Genesis block. In this block, most of the owners or most of the developers will create with empty transactions, and it is up to the context of the owner. Sometimes people write empty transactions, sometimes people write, they transfer some 25, 30 cryptocurrencies also. So it's up to the the context of the owner. So whenever the blockchain is created, the chain gets appended with the genesis block. So according to me, genesis block is nothing but first block which is created by the owner or the developer who is initiating the blockchain. Okay, so that's all about genesis block. So I will explain in the Python program how to create this, but as of now, that's all about genesis block. Who is miner? What miners do? In a decentralized network, miners are nothing but people who adds your block to the blockchain and who validates your block and who validates your transactions that are available in. So you'll have thousands of miners. You'll not only thousand, you'll have lakhs of miners across the globe. Comes on consensus together. Consensus is nothing but mutual agreement together to mine a block. So what is mining? Mining is nothing but adding a block. So validating the block and thereby adding the block to the blockchain. So there are proposed in different blockchain networks. Out of all, POW, proof of work, is a popular consensus algorithm. Today, so I'd be using the same algorithm for auto mining by the Python script. So here miners do a proof of work. The name itself says proof of work, saying that I can add your block. Okay, I have the infrastructure. I have the the fast infrastructure in order to validate your block. That is how proof of work is defined. So miners do a proof of work on the block, thereby who performs the proof of work first will be getting a transaction fee through cryptocurrencies on the blockchain, and the miner who does the POW first will be getting a right to add a block to the blockchain network, and the same data will be broadcasted to all the other miners on the network. So one miner will do proof of work fastly according to the infrastructure, according to the logic he writes. Okay, so based on the logic he writes, based on the infrastructure he had, so he will be getting a chance. Okay, so whenever he does the proof of work first, he will be adding that block to the blockchain, and also he broadcasts the data to all the other miners saying that I have mined this block. So every block will have block number. Okay, so on the block number the data will be broadcasted saying that I have added this block, you also add it. Okay, because so he will be getting the the transaction fee, and all the other blocks and the same block will be added on all the other peers. Okay, on all the other miners validate the block and appends it to the chain on their system. Miners mine for money. What miners will get? Miners will get money in terms of cryptocurrencies, because today one Bitcoin is almost greater than or equal to 7.5 lakh Indian rupee. So that is why miners are a bit costlier, because you need, if you want to mine a block, they need a lot of infrastructure. So in order to maintain those kind of infrastructure, you need some alliances, right? So which are like they will be having some transaction fees in terms of adding blocks to the blockchain network. Okay, that's all about miners. Hope you understood. So let me jump into proof of work. What is proof of work? All the miners will be having lot of infrastructure, or you can say machines, to perform a proof of work. The miner who performs it first will get a transaction fee, so that the miner can add a block to the blockchain. That's what we have discussed so far, right? Let's focus on what actually a miner do in a proof of work. So let us have it. So this proof of work is a simple little logic, okay, simple puzzle logic. So here comes a task which has to be done on the machine of the miner, and the task is to generate a hash value of the block with the difficulty number of zeros. So the miner has to do it, generate a hash value of the block with the difficulty number of zeros. So what is this difficulty? Let's understand that. So generally when data is modified, its hash would modify, right? Here comes a parameter called nonce, which is nothing but number at once. The miner has no right to modify the transaction data to get the required hash. What is the required hash? Required hash, for example, say I have given here. Say this is the hash of the block. Okay, so this is the hash of the block which is not mined. Okay, this is not mined. So we have a hash of the block. How hash is generated? Hash is generated based on the data which is available on the block. Okay, but the block is not mined. Okay, now the miner has to do some proof of work. What is that proof of work? proof of work is nothing but regenerating the hash in such a way that that hash should hold that many number of zeros. For example, say, so here I have given a difficulty level of 8. I have given a difficulty level of 8. So what do you mean by difficulty level of 8? It means that the miner has to region of the block without modifying the transactions. Okay, say I have transferred 10 bitcoins to my friend. Okay, this was the transaction that I made on the blockchain. Okay, I have transferred 10 bitcoins to my friend on the blockchain network. So when you do this transaction, then what will happen? A hash will be generated, but that hash has to be mined properly, right? So then only your information will be appended to the blockchain. If you want to mine it, the transaction hash, which is nothing but block hash here. So here, assume that it is block hash, many number of zeros. So right away, the current difficulty was like 28 to 30 based on the blockchain. But here I have assumed in the article, assuming that my difficulty level is 8. So your hash should start with 8 zeros. Okay, your hash should start with 8 zeros. So this type of hash has to be generated. That is what I have written here. So proof of work. What is proof of work? Proof of work is nothing but regenerating the hash value based on the difficulty level of zeros. Okay. So miner has no right to modify the transaction data. So what is the transaction data here? Transaction data is nothing but 10 bitcoins. Okay, I wanted to transfer 10 bitcoins. There is no right to modify my transaction data. Something should be modified, right? If nothing is modified, then obviously hash cannot be modified. So that is why there comes a concept called nonce. Nonce is nothing but a pseudo number which is generated at only once, and this number will be generated randomly to achieve the required hash. Will be generated randomly so that the hash, a new hash will have those difficulty number of zeros. Okay, so here what is this hash? This hash is generated based on the transactions of the block, and this has to be modified without modifying the transactions. So that comes the proof of work. Okay, by appending nonce value to the block and by updating this nonce value every time in the iterative loop until the required hash is generated. So proof of work is nothing but adding those many number of zeros based on the difficulty level of the network. So generally, as of now, when you look at Bitcoin blockchain network, as of now the nonce value is more than 50 million. Okay, so it means that more than 50 million iterations has been happened in order to generate the difficulty level of the in order to reach the difficulty level of the hash there. So as of now I have taken 8, right? So as of now I have taken difficulty level as 8. So it means that this hash has to be regenerated. This hash has to be regenerated every time until I get that many number of difficulty levels here, that many number of zeros here. So that is called proof of work. Okay. And how to validate a blockchain network? If you want to validate a blockchain network, make sure that every block is connected with the previous block, which is like a linked list. So in the linked list you will have previous address, right? So in the linked list you will have previous address which is written in the block, which is written in the node, right? So here also, so when in the blockchain network, so every block will be holding previous hash, but generally for Genesis block you don't have any previous hash because that is the first block, isn't it? So every block will have a previous hash parameter. So that previous hash parameter will be the hash value of the previous block. So like that, every block is connected there. So I have explained all this in the first webinar also, but here in order to write from scratch, I just wanted to give you a brief. Okay, let's start creating the programs. So what is a step 1? Step 1 is creating a class called block and creating its constructor. Okay, I wanted to create a class. If I wanted to create a class, I wanted to import libraries here. So I have imported from space date time space import space date time. So what is this date time? Date time is a built-in library in order to acquire the current date and time. And from hash library, so hash library is also built-in library, import space SHA-256, which is nothing but the hashing library and this SHA-256 algorithm here. So this is imported from hash library and the class block, and here we have a constructor. So double underscore init double underscore. So this is a constructor here. What we are passing? Object, comma, transactions. So transactions are nothing but the information which you want to store on the block. And previous hash. So as I said, every block will have will store previous hash value, like that, in the blockchain they are connected, right? So previous hash is nothing but previous block hash, and nonce equal to 0. So by default the nonce value is 0. Okay, so here in the constructor, what we are doing, we are recording time. So we are recording time. Date time dot now is nothing but the current time will be stored in the timestamp. And then transactions. So transaction, what do you mean by transactions? Transactions are nothing but piece of information. So which is like, I wanted to transfer 10 bitcoins. Okay, say 10 bitcoins is a transaction, right? So it is called information that you want to store. And previous hash value. So previous hash value, what is previous hash value? The previous block hash. So that is also getting stored in previous hash value. Nonce value. So what is a nonce value? If nothing is passed, so 0 will be appended. If some nonce value, what is this nonce value? A pseudo number. So by using this nonce, so proof of work will be done, right? So as we discussed. So generate underscore hash. So based on all this, we have to generate a hash for this block, right? So generate underscore hash is a function call. We have to define it later, but as of now, it is a function which is used to generate a hash for this data. Okay, so in the step 1, what we did here, we have created a class. We have created some parameters. So what are the parameters? Timestamp, at what time the block is created. Transactions, what is transactions? A piece of information. Previous hash, previous block hash. Nonce, so this is a random number which is generated for in proof of work, but as of now the value is 0, by default value is 0. And next we have generated what? Hash of the current block. So we have previous hash, right? So what is previous hash? Previous block hash. Now we have the current, which is generate underscore hash. So this generate underscore hash will be defining it later, but as of now, so I am just calling it. Okay, so this is a step 1. So we have created a class. Okay, I have explained here what is date time, what is date time dot now, what is transactions, what is previous hash, everything is explained clearly. Okay, second step, creating a member function, generate underscore hash, to generate a hashing of the block. So here, as we discussed, what is this generate underscore hash? Generate underscore hash is a method, right? So which we have called it in the constructor. Now what we have to do, we have to define it, right? Now I am defining it here, def generate underscore hash, so which is nothing but function definition. And what is this? Block underscore contents. So what is this block underscore contents? A third party variable, okay, which is a third variable. So here I am just storing all the parameters. So what I am storing here? Timestamp, previous hash value, and nonce value. I am appending all these parameters. I am appending all these parameters into a string format, because timestamp is not string, right? Transactions is not string data type. Previous hash value is not string data type. Nonce is not string data type. That is what I am doing here. I am typecasting to strf, which is like, in Python. So the typecasting of string can be done, right? And then I just added with plus. What is this plus? Which is nothing but appending. So I just appended all these values to block underscore contents, and I'm calling the function called SHA-256. So SHA-256 is a method which is imported from hash library. So here what I'm doing here, I'm passing this block underscore contents. I'm passing this block underscore contents dot encode of. So here string will be converted into string bytes. So dot encode method is nothing but which converts string to string bytes. So all the string bytes of data will be applied to SHA-256, and this SHA-256 will be generating a mathematical equivalent number. So that will be generated and it will be stored in block. Returning here, what I'm returning here, block underscore hash dot hexadigest, which is nothing but return the mathematical number in terms of hexadecimal values. Okay, so in hexadecimal values you will have A to F, right? And also you will have all this numbers. So all this alphanumeric, okay, all this alphanumeric will be returned from where it is called. So here there are one important step. So what is the one important step? So SHA-256, this is the important step, right? So whatever you pass to block underscore contents, so that will be hashed, that will be hashed in the SHA-256 algorithm, and that data it will be returned to block underscore hash, and from block underscore hash we are passing only the decimal, which is alphanumeric values, by calling dot x digest, because block underscore hash is a object. So from that object we wanted to pass only the respective values which are which are alphanumeric, which is nothing but hash value. So hash value if you want to pass, you need to call dot x digest. Okay, so this is a step 2. So in step 2 we have generated a hash value for the logic, okay, for the data which is getting stored in the block. So all these parameters are getting stored in the block, right? So for all those parameters we have generated a hash value. Okay, step 3, creating a member function called print underscore block to print details on the block in the blockchain. So we have so here what we use multiple print statements to print all the parameters. What is the generate, what is the hash of the current block, and what is the previous block hash. So all these parameters we are just printing there. So in step 3, so these are the 3 important steps while for creating block class. So in the first step we have created a class called block, and then we have created a constructor object. So in the constructor we have taken some parameters that can be added onto the block, something like timestamps, something like transaction, something like previous hash, something like nonce, and the current hash. So all these parameters we wanted to write onto the block. So that block we wanted to add to the blockchain network. Okay, so step 4. So step 2 we have generated hash. Step 3 we have printed all the details, right? Step 4. So here we have to create a new class called blockchain. So previously what class we have created? We have created a class called block. So now what I will do is I will import that class in the new class called blockchain. So I wanted to create a new class called blockchain. So in the new class from block import block. So this is the I have created a class called block, and that class I will import here, and then I will create a class called blockchain in order to instantiate the blockchain. So we have a constructor object also. So here chain is empty, so chain, which means blockchain is empty, chain is empty, and there are no confirmed transactions which are like unconfirmed transactions. But whenever you make a transaction, the transaction will be sent to unconfirmed transactions. So as of now unconfirmed transactions are also empty, and we have a function called genesis block, because when you are creating a blockchain you have to create your first block, right? So no one else will create that. When you are creating a new blockchain you have to create your own genesis block, which is nothing but first block here. So by using this function we have to create a block, but this is not a predefined function, we have to define it. Okay, so in the step 5 I will be defining it, but as of now that is a function call. I made a function call here. Okay, in the step 5 I am creating a genesis block. So in the genesis block the transactions are null, there are no transactions here. Okay, and the nonce value is 0, so I am passing a previous hash value. What is the previous hash value? 0. So there is no previous block hash, right? So that is why I am passing 0, and the nonce value is 0 by default there. And I will generate the hash for the current block, which is for genesis block. So by calling dot generate underscore hash I can generate a hash value for this block, and later I will append this block to the chain by calling self dot chain dot append. So dot append. So if you look at the Python, what is square bracket open and close? Square bracket open and close is nothing but list data type, right? So this will be stored in the form of list data type. So the data structure here is list. So if you want to add something to the list, then obviously dot append comes in place, right? So dot append is nothing but which appends the genesis block onto the chain, which appends this data onto the list, isn't it? So I have given the explanation also. Transactions is empty. So genesis block dot generate underscore hash is generating hash for the current block. chain.append is a method which appends to the chain. Okay, and the step 6, so we have to create a add block function. Whenever you make a transaction, you have to add it, right? So block after certain simple proof of work. Okay, so in the step 7 I will define the proof of work, but in the step 6 I just wanted to create a add underscore block function here. In add underscore block function, what I'm passing here, transactions. So transactions. So I wanted to add a new block. If I wanted to add a new block, I should get the previous block hash, right? So when you know the previous hash block, then only you can add a new block. That is why immediately what I'm doing here, I'm extracting the previous hash value. Previous hash value is nothing but the last block hash value in the chain. So in the last block, so since if I want to access the blocks, then I can use chain variable, right? So because of length of self dot chain, say if your blocks, say if the length of the chain is okay, but index always starts with 0, right? So when you have 3 blocks, index always starts with 0, 0, 1, 2. So that is why we have to subtract it from -1, because you will have only 0, 1, 2. If you have 3 blocks but you have only 0, 1, 2, thereby length of the chain -1 is nothing but the last block ID. So dot hash, so the respective hash will be passed to previous hash, which is nothing but last block hash, and this previous underscore hash is passed to block class here. So what I'm passing here, I'm passing transactions and also I'm passing previous hash. So all this together will be passed to block class. Then what will happen, a block class will be created. So a new block will be instantiated here. Hash, so dot generate hash is nothing but a new hash value is acquired now based on the parameters you pass to the block class, isn't it? So what we are passing here, we are passing transactions and also we are passing previous hash. So nonce value is 0 by default. Okay, a new in the proof of work. Okay, so now the hash is generated for the block and then we have to make some proof of work. So here in Python we are making auto mining. So the program itself will mine. So a function call is made, proof of work of new block. So what happens here, this new block will be sent for mining. So this new block will be sent for mining. So in the step 7, if you see in the step 7, in the step 8, in the step 9 I guess. So in the step 9 we have a simple proof of work. What is here, we have block and we have difficulty level. So what is this difficulty level, 3. Okay, so we will get the block details and also we'll get the difficulty level as 3. So you can make any difficulty, okay, but when you keep increasing your difficulty, so the infrastructure, you should have high caliber infrastructure, high caliber CPUs, high caliber GPUs. Okay, so if you keep increasing your difficulty level, so the time it will take, if you have only 4 GB of RAM CPU, so thereby it takes a lot of time if you increase the difficulty level. Okay, so as of now I have taken difficulty level to 3. So I'm running on Ubuntu operating system of 8 GB RAM, okay, and 1 TB of hard disk. So I'm running on this infrastructure with the difficulty level 3. So here what happens here, so it will generate a hash value for the current block that will be assigned to proof. Okay, so here proof is nothing but current hash value. So here there is a while loop. When while loop will fail until the condition goes false, right? When condition goes true, then obviously it keeps iterating there. So here what is the condition? So here if you see 0 into difficulty. So what is 0 into difficulty? 0 into difficulty is nothing but 0 in single quotation into 3. What is the difficulty level here? It is 3. So 0 into 3. What is 0 into 3? 0, 0, 0. So which means 3 zeros. So when you have difficulty as 8, then 0 into 8 is nothing but 8 zeros. So here we have a while condition. We have a while condition. If the proof is not started, if the proof is not started, not equal to, if the proof is not holding 3 zeros in the starting position, okay. So in the starting position, if this proof is not holding 3 zeros, then it is true, right? If it is not holding 3 zeros, then it is true. Then what will happen? The nonce value will be updated by 1. So that will be updated by 1. So nonce value will get 1. So when it gets 1, then what will happen? Again, a new hash value will be generated because nonce value is updated. Nonce value is updated, thereby a new hash will be generated here. And again it will be compared. again it will be compared. Okay, so again it will check whether the proof is holding first three zeros or not. Okay, if it is not, again nonce will be incremented. So in the 1000 iteration, in the 10,000 iteration, in the 15,000 iteration, so you will get a difficulty, you will get a hash value like, you know, the starting three zeros, sometimes lakhs of iterations, sometimes in the real time scenario crores of iterations will happen on the machine to get the difficulty number of zeros there. But whenever it is achieved, now difficulty is 3, whenever it is achieved, immediately this will become false, immediately nonce value is reset to 0 and return proof. We are passing the new updated value. So this new updated value will be passed to add underscore block. So here we will be getting the new proof. Okay, so we will be getting here, and that block will be appended to the chain. Since it is proof of work is done, what is proof of work here? Proof of work is nothing but generating that many number of zeros in the starting of the hash. Okay, so by making nonce value incrementing by 1 for every iteration, we will be generating a new hash value, and that hash value it is appended here. Return proof, so we are retaining proof and new block, so that block will be added to the chain, isn't it? So after that we wanted to create a function to print the chain. So sometimes we wanted to see what is available on the chain, then obviously you need to define a function here, right? So we need to define a function called print underscore blocks. So in print underscore blocks, so we have written a for loop. So in this for loop we need to pass the chain, and we have to traverse one by one. We have to pass length of the chain. So you know in Python you have range function. So here we have passed the length of the chain. So immediately what will happen? So that many list will be created, and one by one, so member by member it will be accessed and it will be printed here. Okay, so the member by member it keeps accessed and it keeps printing there. And creating a function to validate the chain. So how to validate the chain? We have two requirements here. The current hash should not be modified. Okay, if the current hash is modified, then obviously this blockchain is malfunctioned. Okay, someone has tampered your data. If the previous hash is also not modified, then obviously someone got malfunctioned here. Okay, if the previous hash is same, if the current hash is also same, then that is fine. If the hash is modified, then obviously so they are malfunctioned. So validated underscore chain is very important. You need to traverse through all the blocks in the chain, and you need to check whether the current hash is modified or the previous hash is modified. So like this you need to cross check all the blocks. So this is the validate underscore block. Okay, and we have discussed about proof of work also. Finally we have to make some transactions. Okay, this is the final code where we have to import the blockchain class. Say we have two transactions. Say I have taken IoT example. So we have humidity 23.5, temperature 33.5, humidity 27.5, temperature also 37.5. Okay, some humidity and temperature values. So what I did here, I have created a two transaction. Block 1 transactions equal to this, block 2 transactions equal to this. I have created a blockchain. By using blockchain class. So here I have created an IoT blockchain. And I have called dot print underscore number of blocks will be printed, right? So that those many number of blocks will be printed by using this IoT underscore blockchain. So here, as of now, blockchain is created, you have to able to see the genesis block printed here, isn't it? And then what I'm doing here, I'm adding some block to the blockchain. So what I'm adding here, by calling dot add underscore block of block 1 transactions. So what is available in block 1 transactions? In block 1 transactions we are having humidity value, temperature value. So these values are added to the block by calling add underscore block. Then immediately this transaction will be added to the blockchain after a certain proof of work. And also we are adding second transactions also by calling the same function, which is add underscore block. So here also we will be calling the same function in order to make a transaction here. then what will happen, this block will also be added. So like this you can continuously add some blocks to the blockchain, and then we will be printing, print underscore blocks will print the all the blocks in the chain, and also I am verifying whether the chain is broken or not. The chain should not broke, right? So all the current hash and the previous hash should be same. Okay, so if the data is modified, then obviously the chain will be broken, right? So this is a program. So now let me jump into the programming part. Okay, so I have explained all this. So you will be having GitHub link, you can click on that. When you click on this GitHub link, so it will be redirected to this. Okay, so here you will have the whatever the programs which we have discussed, block.py. So in block.py you can able to see all the program what we have discussed so far. Okay, 3 functions. One is called the constructor object, the second one is hash, generate hash, and third one is print underscore block. Okay, and blockchain. So you'll have blockchain.py. So blockchain.py is also a class which is holding some functions, member functions there, something like print underscore block, something like add underscore block, something like genesis block. So all this we have discussed, right? So let me show you how to execute this. Okay, so this blocks and also the block link under the video description, you can click on those links. Okay, so let me show you the output. Okay, so here let me clone this project. Okay, so let me clone this project code, copy this, let me clone this. Okay, so let me open my command prompt. So this is my command prompt. So let me write git clone. So git space clone space, git space clone space, right click and paste. So I have given a git link also, git space clone space git link, enter. When I hit enter, it will download from my GitHub. Yes, it was downloaded. When you type ls enter, you can able to see same file there, which is my first mini blockchain Python. Okay, my first mini blockchain Python is a folder which we have downloaded. Let me type cd space my first blockchain Python and type ls. You can able to see blockchain.py. so what we have discussed so far, block.py and main.py. so no need to run block.py, blockchain.py, because that is included from main.py. okay, so you have to run only main.py here. So what is there in main.py? So main.py is holding some transactions, right? So let me run the program, sudo space python 3. okay, python 3 is available on my laptop, python 3 space main.py, enter. So password, okay, so you can able to see some block 0 is nothing but genesis block. So that is added at 7.5. okay, that is added at 7.5 today to the blockchain. So what is its transactions? It is empty. Okay, genesis block is not having any transactions there. What is the current hash? Which means the hash of the genesis block. some hash is generated. So based on the transactions and all, some hash is generated. So what is the previous hash of the Genesis block? Previous hash for the Genesis block is 0. Okay, you don't have any previous hash block. And we have made two transactions. If you look at the program, so let me show you the program. So in the program, I have written two transactions. If you remember, I have written two sets of transactions there. I mean one set of transactions, I guess. Yes, 23.5 and 33.5. So let me show you that in the block 1. Okay, after block 0, yeah, block 1 is here. So block 1, so block 1 is also added to the chain. Block 1 is also added to the chain. At what time the block 1 is added? Block 1 is added at so and so time. And what is it transaction? So if you remember the transaction of the block 1, so we have 23.5 and 33.5. So this is the transaction that we made, isn't it? So which is like, humidity colon 23.5, temperature colon 33.5. You cannot tamper this data. If you tamper this data, then immediately hash will be modified. If the hash is modified, the entire chain will be broken. So that is why we cannot modify this data. So in the real time scenario, you will have, after this block, you will have multiple number of blocks, because in the real time scenario, in the Ethereum blockchain, if you see, for every 30 seconds a new block will be added across the globe. So you cannot modify the data. If you modify the data, again hash will be modified. If the hash is disconnected from the blockchain, okay, you cannot access it later. So that is why you cannot tamper the data. As of now, we are having only 3 blocks, right? But in the real time scenario, you will have millions of blocks. 2. So second block is also there. So what is the transaction that is holding there? Let me show you the transaction. It is holding a transaction called 27.5 and 37.5.